Okay guys, now we have an Android project that it has a button that will display a welcome message after touching it. What we want to do now is to build and run this project. To build an Android project, there is something embedded in Android Studio called Gradle. By using the Gradle build system, we can convert an Android project, including source code files, layout files, resources, etc., into an APK file. In fact, after building by using the Gradle build system, these files are packed into the APK file. And after creating the APK file, it's time to run it. So we need an emulator or a real Android device. An Android emulator is an Android virtual device or AVD. In other words, Android emulator is a software which can emulate and run Android OS in your desktop or laptop computer. Let's set up an emulator. We can manage and create Android virtual devices with the AVD Manager. To open the AVD Manager, we can click on this icon or select AVD Manager option from the Tools menu. As you see, by default, there is an emulator here. You can run this emulator or create a new emulator from by using this button. Let me create a new virtual device. In this window, we have a list of profiles for Android virtual devices in different categories. For example, for phone, there are these ready-made virtual devices. You can also have virtual devices for TV, Wear, and tablet. I choose the phone category and select one based on size, resolution, and density. The AVD profiles with the Google Play Store icon next to them means this profile supports Google Play Store. Okay, let me select this one and click Next. In the next window, we have to choose the version of Android OS we want to install on the emulator. We will do this by selecting a system image. Please note that you must choose a system image that's compatible with your app. For example, if your app is on API level 21, choose a system image for at least API level 21. The AVD images with download next to them need to download files necessary to create AVDs. It's good to know that there are two kinds of emulators, x86 and other images like ARM. ARM emulators won't need hardware virtualization. Note that Linux users need KVM. In fact, KVM is a virtualization solution for Linux, but Mac and Windows users need to install the HAXM. By default, virtualization is enabled for Mac users, but to install HAXM on a PC, virtualization must be activated for Windows users. To do so, and if virtualization is not enabled in your system, restart your PC, and when the computer rebooted, enter BIOS by pressing F2 or delete keys, find virtualization technology or something like that, and enable it in your BIOS settings. Anyway, the advantage of an x86 image is that it speeds up the Android emulator dramatically. Okay, my PC supports virtualization and I need API level 26. So let me choose the system image with the release name of Oreo, that is an x86 image. So I need to download it first. and click on Finish. Okay. Let it refresh in the list. Let's go to the next window. In this window, we must choose a name for this virtual device. The suggested name can be a proper name because with the look at the name, you will find out what version of Android this device supports. Also, here are some characteristics of the AVD we've already defined. We can change them by using these buttons. Also, we have a wider range of characteristics here by pressing Show Advanced Settings. For example, here you can enable camera in your Android virtual device. So if your app uses camera, you need to set, for example, your webcam as a front or back camera. Also, you can set memory and storage. For example, you can set how much RAM or internal and external storage this Android device has. Finally, click on the Finish button to return to the AVD Manager window. As you see, a new emulator is made based on your settings. Now it's time to launch this virtual device by clicking on this green button. You can resize it and wait until it loads. As you see, just like a real Android phone, it's loading. The emulator might take a while to load. This depends on your hardware configuration. If your PC supports hacks or your Android Studio and your Android SDK are installed on an SSD storage, the loading speeds up dramatically. Here you are. This is your first Android virtual device. As you see, it's like a real Android phone, and the mouse pointer has the role of your finger. Clicking is just like touching. Now your emulator is ready. Let's run the app to see how it's working. To do so, click on the green triangle button located in the Android Studio toolbar. If your project is error-free, a window opens like this. In this window, you'll see a list of real Android devices that are connected or a list of all your emulators that are running. Pixel 2XL API 26 is the name of our emulator that we've just created. This emulator is running, so it's located under connected devices. So just select it and click on the OK button. After doing this, the Gradle build system takes your project files and Gradle scripts and generate an APK file. And after generating the APK file, it installs and runs the app on the emulator automatically. As you may notice, we're installing an Android app directly on the device, on the emulator, instead of using the Google Play. This is called side loading, the process of loading apps from sources other than the Google Play. Okay. This green mark means your project has built successfully. Once the application is installed and running, your app gets displayed on the AVD screen like this. And then you can see the main activity. Congratulations, you could successfully run the project. Now let's play with our first app. As you see, by touching the button, a welcome message is shown to the user, and after a while it disappears. In fact, it's a toast message. A toast is a short message that notifies the user of some occurrence and then goes away automatically. It's called toast because it pops up like toast out of a toaster. But you may say, hey, wait a sec, we've placed this guy in the middle of our layout. But at runtime, it's not in the center of the screen. Why? Well, you're right. The short answer is that this button is located under a constraint layout. In fact, the constraint layout is the parent of the button. So we need to create some connections like this. So now if I run it again, it removes my first app from the emulator, builds the app based on changes, and installs it again on the emulator. This time, you will see that the button is positioned in the center of the screen. Okay. I'll talk deeply about constraint layout later. Okay. Note that if your app has an error, for example, an error here, you miss the W, the uppercase W, your application won't run. Instead, it shows some errors here. Let me close the emulator. Note that if the emulator is not running and you try to run a project, Android Studio first launches the emulator and then runs the app. Okay, there is a toolbar here that contains a series of buttons. Buttons to turn off the device or rotating the device, etc. Let's take a look at these buttons in the next video.